Now we will discuss the topic which is called as transformer on no load. We have already discussed the things that how the transformer works. Now we will discuss about a transformer on no load. First of all, a transformer is said to be on no load when its secondary is open circuit and it draws a current which is called as the exciting current to meet the iron losses demand only. This no load current or exciting current has two components. One is called a magnetizing component, which is also called as the reactive component. Another part of the I0, which is called the exciting current, is the working or active component. It is also called as the core loss component. So, rather than writing it like this, I can also write it like this is called as IM, which is called as I magnetizing. In some books or in some book references, it is also called as I phi. And the working component is also called as IW, which is called I working, or it is in some books it is written as IC, which is called the core loss component. So I can say that I0, which is called as the exciting current, it has two parts. One is called your magnetizing component. I'll write it as IM or I phi, whatever. And another is called the working, active or core loss component, which I can say as IW or IC. Here I use IC. In phasor representation, I can also show this thing that how this I0 exciting current is shown. If I say that this is my IC, which is called a core loss component, and I have I phi, which is called my magnetizing component, it becomes as I0 now, which is called as my magnetizing component. Now coming to the parts, what are the uses of this I0, I phi and IC? As we have already discussed that on no load condition, the primary of the transformer, when the secondary is open circuit, but obviously my transformer is open circuited, and I will draw only one current, which is called the magnetizing current, that is I0. It has two parts, which is called magnetizing component. Magnetizing component is used for production of the flux in the core and always lags behind by 90 degree by applied voltage. So this is lagging by 90 degree, and this is in phase with your voltage, which is working or active core loss component, which is now I've shown this thing, which is in phase with this one. So I can write another thing. And what is the use of working active loss component? Is to supply the core losses in the core losses in the transformer. I can also write this thing in this way, that IC is equals to I0 cos phi, and IN or I phi is equals to I0 sin phi. So another thing, by looking at this thing, I can say that my cos phi, which is also called as power factor, is equals to IC upon I0. From this, it is coming as cos phi, which is called a power factor, is equals to IC is equals to IC upon I0. One more thing, by looking at this thing, I can write that I0, since it is the vector notation, I0 is equals to under root of IC square plus I phi square. One formula, two formula, 3 and 4. All these formulas are very much important in solving the some questions of transformer.